And welcome to this month's version of the FDTD GOES application webinar. We're very happy today to have Mike Stavish, the SOO in Medford, talking about thunderstorms, smoke, and fire. Next slide, please. This, of course, is one of a series of applications webinars. You can see the URL in that blue box. Dan Bicus and I are always looking for content. If you have something where you've used GOES satellite imagery in your office for a particularly good reason, or for any reason, please let us know and we can help you put together a short presentation. Next slide, please. Mike will talk about 20 minutes and we will have questions. You can wait till the end and ask your question in person. We'll unmute you, or you can send them to us in the chat box. Don't press hold, mute yourself when you're speaking. Take it away, Mike. Thanks.
Thank you very much, Scott. Thank you everybody for dialing in. Welcome to Mike Stavish's living room, dialing in live from Medford, Oregon. As you may know, we've had a significant event nearby. The WFO has been challenged, and there's a lot of people in Southwest Oregon and in Western Oregon that are being affected by fire right now. On that note, I did have a presentation to give you about a recent fire event in Northern California. And we'll go ahead and proceed with the presentation at this time. So the title of the presentation is Thunderstorm, Smoke, and Fire. And we're going to talk a little bit about how we used GOES West to investigate convection near the Caldwell Fire in Northern California on July 27th. A quick outline, we'll talk about some details of the fire, talk about the radar, challenges of the day. On that day, we'll talk about some IMET coordination that occurred, which really kind of inspired the talk today. We'll talk about how GOES West saw some of the thunderstorms in and around that Caldwell incident that day, and a few of the different channels and radar satellite products that we used and looked at. An aha moment with the day cloud phase RGB, and then we'll talk about a couple of other GOES West products that we looked at, including the fire temperature and some aspects of the 1.6 and 3.9 imagery, and a couple of more tidbits. The image there is just from some California fires. It's the geocolor earlier in August. Moving along here, we'll talk about the Caldwell Fire. We're looking at Northern California, far Northern California and Southern Oregon here. The bright white line through the center there is the Oregon-California border. The Caldwell Fire perimeter is in red. Take a look up here over toward Medford. There's the KMAX 88D. It sits at about 7,500 feet MSL. Up in the Siskiyou Mountains, Medford down here is about 1,300 feet MSL, and much of the what we call the east side over here is about 4,500 feet or higher in elevation. So there's a lot of elevation differences here that we're looking at. One thing to talk about here is traditionally the radar data from KMAX has been challenged, if you will, over the east side. We don't have as good a coverage east of the Cascades, which runs about north-south here along the Jackson and Klamath County line. East of the Cascades, we don't have as good a coverage from the radar traditionally because the beam ascending as you head east, and also some beam blockage concerns. So traditionally, we haven't had that great of coverage east of the Cascades. We do have a new minus 0.2 degree elevation scan that allows us to see some things out there that we haven't seen traditionally in time. We've seen a lot more boundaries with that minus 0.2 degree slice. So this was between 21 and 22 Z on the day of concern, and you can see there was convection approaching this fire. This is just a zoomed in look at that perimeter. Now, at the time of this convection, this radar imagery, this perimeter was really not this big. So just consider this fire to be about the southern half of this perimeter at the time. And what we're seeing here is convection and probably pyrocumulus along the flanks of this fire perimeter in this area, and some smoke plume, while at the same time there's convection approaching from the south and southeast. We're going to go ahead and run the loop here, and you can probably see some of these convective outflow boundaries that I discussed earlier. This is unlike stuff that we've been able to see really in the past, just as a side note. So very interesting to see the boundaries meandering around our east side. Tom Wright was the incident meteorologist on this incident. The Caldwell Fire was part of the July complex at this time. And it just so happened that I was in the office this day. I was working a shift, and we got a call from Tom, and he said, "Hey, Mike, do me a favor and take a look at the radar and take a look at the satellite, and maybe you can help me out. I'm not seeing anything north of the fire here." And Tom was concerned about this area. Of course, he could see the convection coming from the south, but there was some confusion as to what was going on up north here. He was seeing some things in satellite that suggested there was storm activity up here. And he said, "Hey, what's going on? Can you help me out?" So of course, this is a pretty significant situation for an IMET to be in. Anytime you're on a fire and there's convective activity approaching, you've got firefighter safety concerns, you've got outflow boundaries, it's a chaotic environment, you need to communicate to the resources on the fire, etc. So this is not a situation to be taken lightly. Here's what was appearing in the GOES West visible that day, half-kilometer visible imagery. I put a circle there for the approximate location of the fire perimeter. So you can see the bumpier cumulus developing to the south and southwest with the thunderstorm activity. And you can also see a broad area of what appears to be development to the north and northeast of that fire location. In addition, on the Cascades and Siskiyous, you see convective cells developing. And so quickly it becomes a pretty complex environment to look at in satellite imagery for the IMET. And looking at the visible picture here, it looks kind of like the whole area is just sort of filling in with convection. Here is what we call the standard IR, or the 10.3 micron. Looking at this, we see some differences between the convection approaching from the south and that which is sort of occurring over the fire and to the north. All these tops in the IR here were about -40 or colder. And so it's assumed that this is all ice. But we still see some differences here. But really, as if you're looking at this infrared imagery to kind of help you figure out, is there convection to the north of my fire and to the northeast of my fire, that leaves some things unanswered. It's a little bit unclear. Tom may have been looking at this infrared imagery up here, north of his fire, and thinking that there was convection in that area, while at the same time, as we just saw here previously, the radar wasn't showing anything. And so trying to figure out if he's going to have outflow from the north and or from the northeast, while at the same time having a threat from the south, was a challenge at the time. So we did a little bit of poking around, and we'll show you where it went from there. By the way, here is the GOES West Sierra Geocolor RGB. This is a local favorite. Many of the meteorologists are very fond of this imagery. It gives a very intuitive look at the atmosphere and the terrain and the earth. As you can see here, most of the thunderstorm activity is just bright white cloud. You can see a general haze around the area from the smoke, but you're not seeing a lot of detail delineating anything in the fire region with really convective activity to the south or southeast of the fire location. In contrast, here's an image of some August fires over California, and you can see how the smoke with this fire activity is looking much different than the associated clouds on the periphery of this big smoke plume. You might have some AC, altocumulus, moving over the top of the smoke, And on the periphery, maybe some convective clouds. And there's a big difference to the appearance here. You can, there's an intuitive feel of saying, hey, this is just maybe just generally smoke, and this is just generally cloud out here. And just in contrast to what we just saw, that's a lot different, where we just saw basically bright white in the previous geocolor. So this was our aha moment. This is when we pulled up the day cloud phase RGB. Traditionally, the day cloud phase is good for showing initial stages of cumulus development, as you can see really in the teal coloring here. And as they progress into thunderstorms and get greater vertical growth and become more ice dominated in the upper reaches of the cloud, you get the yellows and brighter yellows, even a whitish yellow, as you get up to the smaller, denser ice crystals of the anvil and storm tops. But in this case, I'm looking at this saying, what's all this pink? And this is really not something that we were traditionally used to looking at or even using the day cloud phase for. And you can see this plume coming up out of the fire incident here on the Caldwell perimeter is governed by this whitish pink mainly, and hardly, if any, yellows at all. And so looking at that, it was kind of like, hey, this is really showing us that this was kind of a smoke-dominated cloud environment, and was really just sort of pyrocue and anvil blow-off that was somehow largely influenced by smoke. In fact, I was at the office over here in Medford this day, and I could see the advancing layer of pink here coming overhead, and it was clearly just a smoke layer being ejected westward from the convection over the Cascades here. This whole region between the fire perimeter and the Cascades had a lot of smoke in it that morning. So a lot of the stuff in here was largely mixed with smoke. So we'll take a look at a few more products here. This was the fire temperature RGB. Very useful to look at these days, especially over the past couple of days. We've gained a lot from looking at the fire temperature RGB. You can see the heat from the fire here. That signature probably coming from the 3.9 element within the RGB. But also there's just a general different feel to what we're looking at here. The convection in the south has a much darker appearance to the cirrus, while over the fire region and convection over the south Cascades has a brighter appearance to the cloud tops. And really what came out of this on our end was that the cloud condensation nuclei contributed by the smoke in this environment led to a denser upper canopy of ice crystals in this region and a higher reflective component. And a couple of channels that we'll look at here that really display that well are the 3.9 and the 1.6 micron. So here was the 1.6, otherwise known as the snow and ice band. And this shows this pretty well. You can see the darker cirrus to the south. This is all convection again. And the convection ongoing in and around the fire area, including the pyrocue and convective cells associated coming right off the fire, show a much brighter appearance. And that's due to that denser ice crystal nature of the upper cloud there. Here was the 3.9 shortwave IR. Of course, you know, this is widely known as a very important channel to monitor fire. A lot of the same type of thing can be seen here. This is a longer loop running between 18 and 0Z that afternoon. So this is a long 6-hour loop where we can actually see, you know, the fire perimeter lighting up early on, but then just this different nature of the upper characteristics of the upper levels of the cloud there. And again, we think this is because there was a lot of smoke infused in this convective activity here, and it just led to a very different environment. What we'll also see here is that in this environment where there was a lot of smoke that can be shown in that imagery, there also appeared to be limited convection overall. And we've seen that a lot as a result of smoke layers in the past. They tend to limit the the heating of the ground, and things tend to stay a little bit more stable. Not entirely, but that tends to be the case. Quick image here provided by my friends at CIRA. What we know about this environment when you have smoke versus no smoke on the left, fewer cloud condensation nuclei, and you just have a less dense upper canopy of ice, larger ice crystals and less dense. And on the right, in the smoky environment, you've got more cloud condensation nuclei with the smoke particles, and they lead to a denser level of smaller ice crystals in the upper reaches of the cloud, and hence more reflected energy from the 1.6 and 3.9 channels. I just thought I'd toss in a couple of things that we investigated here also with regard to how much lightning occurred and what was the polarity differences of the lightning that occurred in and around that smoke region. And this was just during the 1 hour loops that I was showing between 21 and 22Z. We did see a little high concentration of the positive strikes here. Those are in red of the convection over the South Cascades that ejected that smoke plume out to the west over Medford. And even here on the fire perimeter, we had a positive strike. But just a little bit of investigation. This is from the local Medford archive of lightning created by Shad Keene and Charles Smith locally. I went ahead and overlaid a piece of the day cloud phase RGB on top of that lightning, and this was the lightning for really the majority of this event between 21Z and 3Z that evening, and just kind of roughly outlined where this day cloud phase was indicating these different colors as a result of the smoke contribution, just to say, hey, was there any kind of big difference in the resultant lightning that occurred in this region? It did appear there may have been some greater population of positive strikes, but in general also maybe just less convection occurred in this area than in the surrounding areas. Wanted to point out an interesting feature. I took a look at the next day. This was the Veggie Band, the 0.86. As been known, you can see fire scars in the 0.86 pretty good, in addition to other features after convection, for instance, hail swaths, etc. But the burn scar did show up very nice here. This is actually was coincident with the Lava Beds National Monument in Northern California, so there was a significant fire scar visible there. I also took a look at the VIIRS imagery from the SSCC VIIRS Today page. This is the, I believe, the false color imagery. And this shows a nice, this was before the fire and this was after the fire. So again, you can see a nice burn scar feature in the false color imagery there. So just a quick points to wrap up here. It Goes West did help us in understanding the smoke environment associated with the Caldwell Fire that day, helped to clarify various characteristics in the mix of clouds and smoke and convection. Especially revealing was the day cloud phase RGB. The importance of this intelligence to an IMET could be quite valuable in understanding the environment. Smaller ice crystals in the smoky updrafts are certainly delineated from non-smoky updrafts, and that's quite revealing looking at the 1.6 and the 3.9. In general, we see smoke limiting convection, and in this case, aside from the convection seen on the flanks of the fire, the broad area of smoke and smoky clouds appeared to limit the convection north and west of the fire. And the day cloud phase and fire temperature RGBs, including the 1.6 and 3.9 channels, really help to show major differences in the clouds and thunderstorms versus the traditional 0.64 visible and 10.3 micron that we might be looking at, and even the geocolor RGB. One interesting note about this fire is that that afternoon and evening of the imagery we were showing, this fire spread by almost 25,000 acres to the north, and that was a major burn that night. So I wanted to give thanks to Dan Bikos and Scott Lindstrom and Louis Grasso and Curtis Seaman for your valuable contributions to the presentation. And say also thank you to Tom Imet from Medford for your input and your dedicated professional service. We'll end there and we'll take any questions.
Thanks, Mike. That was great. I do have a question since you have fires ongoing now. Is the satellite presentation of the fires that you're experiencing now similar to the was for this Caldwell event?
Yeah, yesterday, Dan, we were largely focused on the fire temperature RGB and showing us where incidents were actually occurring. The Medford WFO, of course, and myself included, I was watching closely areas to the south of Medford here where evacuations were underway. Fire activity was certainly visible out the window of my house to the south as fires had developed near Ashland and were moving through the Talent area. And there was a period in the afternoon where the initial smoke, which was quite scary given the dry and windy environment we had, the smoke decreased and sort of disappeared for a little while, which may have led to a little bit of a false sense of security that things were strangely improved given that the wind hadn't stopped. So we were watching that fire temperature RGB closely and watching for any heat signatures on the ground. And there was indication also that maybe the fire just had moved into lighter fuels and wasn't producing as much smoke and heat as it was initially. But another thing we had happen yesterday, I think there was a yaw flip on Goes West, and there was a period of about an hour or so where we didn't get imagery. So that was an interesting note from yesterday.
Was there not as much convection with this yesterday with all the dryness?
Right. We weren't looking at convection at all yesterday. This is mainly a dry offshore wind event, so
right.
We weren't really challenged with a mix of thunderstorms and smoke here.
Okay, if anyone else would like to ask questions, let's see if I can figure out how to do this. I think you can unmute yourself now, I think. And ask a question. There was a question submitted in the chats, but that was about the lightning. So we've already talked about that.
Hey, Scott, this is Dan Lindsay. Can you hear me?
Yes.
Okay, great. Mike, great presentation. This is a topic that is near and dear to my heart, actually, is the effect of these, the effect that smoke has on the microphysics and ultimately what you can see from the reflection in those shortwave IR bands. So excellent. There's been a number of papers on this topic, which you probably have seen some of that. And I'll also say that the Dave Peterson from the Naval Research Lab has developed an automated pyro-CB detection algorithm that runs in real time and actually keys in on this very thing, on basically looking for these small ice crystals in those near IR bands in order to flag those. It's kind of interesting, and you can find that on the NRL website. I'll try to find the link and post it here. And then I do have one question, and that is regarding the geocolor. Did you get that set up so you can pull it in on LDM and display it on
Someone else wanting to talk?
Hi, Dan, Mike here. I missed the very last part. Did we get it set up so we could pull it in?
Yeah, we were working on getting that pulled into Western region via LDM, so you could get it in AWIPS. Is that how you have the data coming in now?
That's right. Yes, it is.
Okay, thanks.
I believe we're pulling in. We might be locally pulling in more than we're supposed to be pulling in right now. In fact, we might have some data sets to be pared down and set up more of a tiled ingest. I don't know if we've set up that tiled ingest quite yet. So yeah, thank you, Dan. Thank you for the question. It was nice to hear from you, and I'll check out some of those resources you mentioned.
Are there any other questions?
Hello.
Yeah, go ahead.
Louis Grasso here.
Hi.
In the beginning of the loop of the 27 July fire, when Dan Bykos and I were looking at this earlier, a few days ago, we noticed developing cumulus. I think you had showed 10.35 or something, the satellite from GO 17. Keep going back. Yeah, that one. So you see a circle indicates the approximate area of the fire, and then right about there, at the very end of the loop, you see to the south, you have what appear to be rapidly growing towers with somewhat circular anvils. And so when Dan and I were looking at this, what came to mind was a particular hazard where there was a fire. Dan Lindsay, if you're still on, maybe you'll remember. There was a fire in Arizona, and firefighters were working on this particular fire. I think it was on a hill. Behind them was dry thunderstorms, and you could see all the Virga coming down because, ironically, somebody had a time lapse. And what happened was an outflow boundary formed behind all the firefighters, advanced forward, and caused the fire to expand rapidly and cause fatalities. And so when we looked at this particular loop here that you have, we looked to the south. Right near the end, you can see a circular anvil expanding. And even further in time, there's one just to the north-northeast. South of we were wondering there you had any feedback from an IMET or anybody where these particular convective elements would have the potential to produce outflows that would move north towards the burn area.
Yeah, thanks, Louis. You know, I didn't have any insights on this cell that you're mentioning to the south. I just do know that either that one may have contributed significantly, but in general, the outflow from the cells that came from the south did produce a northward push on that incident, and basically produced the northern half of that fire perimeter that we showed earlier on. So, you know, this perimeter, like I said, at the time was about half the size, and about half of this grew during the afternoon and overnight of this incident. So there was certainly quite a contribution from the south push and the convection in the south. And you can see that the Hale algorithm was keyed in on that triggered on that cell that you're mentioning here. I suppose that's the cell in here maybe that we saw on satellite that you were referring to. But really I couldn't contribute the south outflow to any individual cell here, but that's an interesting aspect you bring up. Thank you for that.
All right, thank you.
Okay, any other questions?
That's just what I was talking about.
Let's see. Matt Bunkers had a comment. Did you see that, Scott?
No, I haven't. Go ahead and read it.
Oh, I think he left, but he said, we have noticed an uptick of positive CGs with thunderstorms this year where there was a lot of smoke in the air, about 50-50 plus or minus. Not sure if this is consistent signal, but your lightning plot supports it.
Yeah, I think by and large, we've seen that as the case. I know there's some research out there that has talked about positive versus negative strikes with convection. And I think just anecdotally, we've seen it here to where we see more positive versus negative strikes, or we do see an increase in positive strikes in smoke regions where there's convection. So that's an interesting topic study to look closer at.
This is again, just to quickly follow up on that. I agree with you. There's been some studies looking at that. In fact, when you significantly modify the cloud microphysics within these clouds, which is what happens when there's a bunch of low-level smoke, I think it can cause an inverted charge structure that might be more supportive of positive strikes. And that there was some research by Larry Carey in the early 2000s along these lines, I believe, if I remember right. Anyway, that's all I wanted to say.
Okay.
Brian Mata has a question. Go ahead, Brian. Should be able to speak.
Can you unmute yourself?
I'll read off Brian's question. Was there any flash flood concern for the fire zone?
Good question, Brian. We didn't have any conversation on any potential flash flooding this day, as far as I can recall. The terrain in and around the fire perimeter there is not real steep. But yeah, I don't recall any of that. I know that there was probably a higher than average PW this day, but the short answer there, Brian, is no. No flash flood threat, and nothing was monitored. Well, we're always monitoring that kind of thing, but I didn't think there was any elevated concern on this day for that.
Okay, any other questions from anybody?
Well, I'll butt in and say thank you very much, Mike, for giving this presentation. It was excellent. And we will have another FDTD webinar. So check your calendar, check the calendar. It's in the planning stages now. Thanks, Mike.
Thank you guys very much. Appreciate it.